In this video, we're going to learn to use some of the simplest trig identities that you know. These are identities you already know. They're on your formula sheet, but you shouldn't have any trouble memorizing these because, as I said, these are identities that you've learned. The first set we're going to call the reciprocal identities. And as I said, these identities are on your formula sheet. But you'll recall when you learned, for example, cosecant of theta, I taught you that this is 1 over sine of theta. It's the reciprocal of sine of theta. Similarly, you learned that secant of theta is the reciprocal, or 1 over cosine of theta. When you learned cotangent, you learned that that was 1 over tangent of theta. And therefore, you can just take these and extend them. If cosecant of theta is the reciprocal of sine of theta, then sine of theta must also be the reciprocal of cosecant of theta. Cosine of theta is 1 over secant of theta. And tangent of theta is 1 over cotangent of theta. Those are the reciprocal identities. The other set of identities that you're going to need to use are what we call the quotient identities. And they are simply your unit circle definitions for tangent and cotangent. You learned that tangent of theta is equal to sine of theta over cosine of theta, and you learned that cotangent of theta is equal to cosine of theta over sine of theta. So what can we do with these two sets of identities? Well, if we're given an expression such as cosecant of theta times tangent of theta, and we're asked to simplify this expression, well, that means we want to put it in the simplest terms we can. If we can express it as a single trigonometric function, such as sine or cosine or tangent, we'd like to express it that way. If we need to use a reciprocal function, if we need to express it as secant or cosecant, that's okay, but it wouldn't be our first choice. So let's just see what we can do to simplify this. We've got we've got a reciprocal function, cosecant, and we've got tangent here. So, well, we know that cosecant is the same as 1 over sine of theta. So let's start by rewriting this as 1 over sine of theta times, well, how can we express tangent in terms of sine and cosine? Well, from the quotient identities, which hopefully you have this just in your head, we know that tangent is sine of theta over cosine of theta. So let's write this as sine of theta over cosine of theta. And hopefully you can see right where this is going. It's not very complicated. We can simply cancel these out. And this now becomes 1 over cosine of theta. Well, I'd rather not write that as a fraction like that. And 1 over cosine of theta we know is equal to secant of theta. So there we go. There's our first simplification. So we can say that cosecant of theta times tangent of theta is equal to secant of theta. One more example. We're asked to simplify cotangent of theta over cosecant of theta. And once again, these can both be written in terms of sine and cosine. Cotangent is the same as cosine of theta over sine of theta. And cosecant is simply 1 over sine of theta. And then that, of course, we can rewrite as cosine of theta over sine of theta. Keep. We'll change the division to multiplication, and we will flip the fraction in the denominator. This becomes sine of theta over 1. And then again, like in the last example, we have some canceling that we can do. The sines cancel out, and we're left with cosine of theta. Now let's look at a method we can use the calculator to check our work. It's not that difficult, but there are a couple of tricks to it. So here's our initial expression right here, cotangent of theta over cosecant of theta. So what we're going to do is we're going to put that into our calculator and graph it, and we're going to put our simplified version into the calculator and graph that, and the graphs should match one another. Okay, so the first one, cotangent of theta over cosecant of theta. Go into our function editor. Now, to enter this, we have a complex fraction, but neither cotangent nor cosecant have a button on this calculator, so we have to use what we know about those two trig functions to use the buttons that do exist in order to enter them. First, we're going to set up a complex fraction template. Okay, so we're going to do a fraction, and then in the numerator, we're going to create another fraction. Because when we plug in cotangent of theta, we actually have to put that in as 1 over tangent of theta. Of course, in the calculator, we use x instead of theta. Then again, in the denominator, we're going to do the same thing. We're going to set up a complex fraction, or a fraction template, within the denominator here. And this time we're going to put 1 over sine of x. And we'll take a look at that graph. Well, actually, you know what, let's let them graph together. Our solution was, we'll take another look at what our solution was, cosine of theta. So we're going to put that in red, cosine of x. And now we'll graph them. You can see in blue, this is our original expression, cotangent of theta over cosecant of theta. It's graphing a little bit slowly because it's a more complicated expression for the calculator, and it just takes a little bit more processing power to graph that. But look at the red line. There's cosine of theta, a much simpler expression, but notice that it maps exactly over the blue graph. And since they match, we know that our solution is correct.